In dual nature chapter, some important equations I am going to write here. So the first equation is H nu is equal to, okay, H nu is equal to, H nu is equal to kinetic energy maximum plus phi naught. Okay, kinetic energy maximum plus phi naught. Then what do you mean by this kinetic energy maximum and phi naught? Phi naught is nothing but it is called work function. It is called work function. And kinetic energy maximum is the maximum kinetic energy of the electron. Okay, so we can write kinetic energy maximum is equal to maximum kinetic energy of the electron. Maximum kinetic energy of electron. So just imagine that this is a metal plate. Okay, this is a metal plate. So a light incident on the metal surface, and this light consists of photons, and each photons has its own energy, that is h nu. So the electrons in this particular metal plate will absorb the h nu energy from the light, and it will use this h nu energy for two purposes. Okay, one part of the h nu energy is used to escape from the metal surface. Okay, one part of the H nu energy is used to escape from the metal surface. So that minimum energy required to escape from the metal surface is called a work function. Okay, and that work function is denoted by the letter phi naught. Okay, and another part of the energy is used for what purpose? It is used to move forward. Okay, so move forward means the kinetic energy maximum. Okay, so one part of the energy used to escape from the metal surface, that is work function. Another part is used to move forward. I mean used to move towards the collector plate. So that's why we can write H nu is equal to phi naught plus kinetic energy maximum. From this equation, we can write the equation for kinetic energy maximum. That equation is nothing but kinetic energy. That is, we can write kinetic energy maximum is equal to H nu minus phi naught, or you can write phi naught. Yes, phi naught H nu minus phi naught. Okay, and this is second equation. So first equation in terms of H nu is equal to phi naught plus kinetic energy maximum. And the second equation you have to remember in this chapter is kinetic energy maximum is equal to H nu minus phi naught. There is an equation connecting Planck's constant and threshold frequency, that is phi naught. Phi naught can be written as H into nu naught, where nu naught is called a threshold. Okay, threshold frequency. Okay, and fourth one, we can express the kinetic energy in terms of stopping potential, that is E into V naught. Kinetic energy maximum is equal to E into V naught. Okay, then another equation is there. We can express energy like we can express kinetic energy maximum in terms of wavelength, that is kinetic energy is equal to h nu minus phi naught, that is kinetic energy maximum is equal to h into nu minus phi naught can be written as h into nu naught, and kinetic energy maximum is equal to nu can be written as hc by lambda minus hc by lambda naught. And kinetic energy equation can be written as kinetic energy maximum is equal to Hc into 1 by lambda minus 1 by lambda naught. So this is another equation of kinetic energy in terms of wavelength and threshold wavelength, the lambda naught. Okay. Then another equation we can express this above equation in terms of the stopping potential. Okay. So the stopping potential V naught, we are going to derive the equation for V naught here. So kinetic energy equation is E into V naught, right? We learned this formula here. kinetic energy maximum is equal to E into V naught. We can express kinetic energy in terms of stopping potential. E into V naught is equal to, what is kinetic energy? Kinetic energy maximum is equal to hc into 1 by lambda minus 1 by lambda naught. So instead of kinetic energy maximum, I wrote E into V naught. So that is equal to hc into 1 by lambda minus 1 by lambda naught. Okay, then V naught, the stopping potential equation is equal to hc by E into 1 by lambda minus 1 by lambda. So these are the important equations from the dual nature. Okay, then one another graph problem will also come for the exam, but actually that's a little bit theory part. Okay, that part I will share.